equations, how to write and balance chemical equations. This chapter 4 is divided in 3 units, unit 7, 8, 9, and you're going to find the videos, short videos for each unit that will help you to understand better before you go to the class. So a balanced chemical equations use symbolism to represent both the identity and the relative quantity of a substance undergoing chemical or physical change. And it's really important to know how to read and how to write those chemical equations. The substance undergoing a reaction we call reactants, right? And the formulas are placed on the left side of the equation, as you see over here. So we have the reactant side. So we have reactant 1 and 2. So that's methane and this oxygen. And the substance generated by the reaction are called product. So they are placed on the right side of the equations. So we have product 1, the carbon dioxide, and product 2, the water molecule. So this arrow is dividing the reactants from the product, and the plus sign here is separating individual reactants and product formula. So another very important thing here is that you always use the smallest whole numbers of the coefficient. Stoichiometric coefficient is the number that you see in front of the compound, substance, or element. So when you see number, that means we have 1 methane, 2 oxygen molecule, 1 CO2 molecule, and 2 water molecule. So that indicates the number of molecules, substance, or elements that we have in this reaction. When I say the smallest number, I mean, imagine if you have 4CH4 plus 8O2 given 4CO2 plus 8H2O. So I can have it smaller if I divide all the numbers by a common factor. So if I divide all by 4, what I'm gonna have is 1, 2, 1, 2, the smallest number. Another important information that the equations can give to you, besides the reactants and products and the stoichiometric coefficient that is really important, is the state of matter. So here you have a gas and a liquid, but you can also find the solid, so represented by S, and aqueous, so it's a pill. Okay, so and another very important thing is to know how to make difference between stoichiometric coefficients, which is this, and subscript. It's really important to understand this difference because subscript, it cannot change. You never change the subscript. For example, if you write down this when you see that, you're gonna tell me this is water molecule. But what about if you change the number of oxygen? This is a hydrogen peroxide, right? So that means you can never change the number of subscripts over here because that is the density of that molecule, the density of that substance. So you never change. Another thing here, if you don't understand this, I can give you an example. Like imagine if I have 2 smile faces over here. So when I look to a smile face, I have 2 eyes, right? 1 nose and 1 mouth. So I have 2 of those, so I can put it here 2. So I know that in the total, I'm gonna multiply these numbers, the stoichiometric coefficients by each element. So we're gonna have 2 times 2 will be 4, 2 times 1 is 2, and 2 times 1 is 2. So I have 2 mouths, 2 nose, and 4 eyes in the total. But I know that it's an individual molecule over here. But what about if you write down E4 and 2M2? This is a completely different monster because now I'm gonna have 4 eyes, 2 nose, and 2 mouths. So that is a complete different substance. Okay. Another thing that is important is we always try to make whole numbers. As I said before, you cannot have fraction. It's not common to find fraction. So in this case, what I should do is multiply my whole equation by 2. So we're going to have 2 hydrogen plus 1 oxygen given 2 water molecule. So now I have whole numbers over here. Okay. And the other important thing is based on the atomic theory and the conservation of mass, the atoms that you have one side, you need to find that in the other side. And the same atoms and same quantity. Okay? So for example, here, if you go look at this, we have, let's imagine this is the reactants, and this is the product. Okay? So in the reactant, I have 1, 2 oxygen. This is oxygen. And I have 1, 2, 3, 4 hydrogen. See, they are together. So those we call the diatomic molecules. So the diatomic is element that cannot be found by itself, like hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those elements you never find by itself. Okay, if they are bound, okay, you're gonna find HCl. So you say it's like, oh, hydrogen is by itself. No, it's bound with the chlorine. But if they're by itself, you're gonna find H2, O2, fluorine 2, chlorine 2. They are diatomic. Okay, this is why I have 2 hydrogens together and 2 oxygens together. So let's get back to reactants and products. So in the product here, I have a water molecule. So I have 1, 2 oxygen. So same atom, same quantity, and they have 1, 2, 3, 4 hydrogen. So see, we have the same atoms and same quantity on both sides. So to balance equations, we base on atomic theory. So atoms cannot be created or destroyed in a chemical reaction. That means if you have carbon on one side, in the other side, you're going to have carbon as well. Number of atoms and type of the reactant must be equal to the number and type of atoms on the product. So if I found 2 carbons on one side, the other side, you need to find 2 carbons on the side. And when they say like they don't change, just the atoms don't change by itself. If I have a CO2 or I have a CH4, imagine it, plus oxygen giving CO2 and water. So this is a different product, right, from this. But the carbon has the same property that before. So they are only bound with different elements, forming different compound, okay? And the mass before reaction must be equal to the mass after reaction. And that is, if it tells you that I have 80 grams in the total over here, CH4 plus O2, and this side, I'm gonna have 80 grams as well. Doesn't matter if I have 36 grams of water and 44 grams of CO2, this in the total, I need to have 80 grams because I start with 80 grams. Is it the same thing that if I prepare a cup of chocolate milk? I'm gonna put 200 grams of milk and 20 grams of chocolate, for example. So at the end, I'm gonna have my chocolate milk over here and the total of 220 grams. That is not magic because I didn't make a pure more chocolate or more milk. So that will be 220 grams, same thing. So let's use a very common example just to balance the reaction. So let's imagine that we have 1 burger patty, 1 bun, 2 slices, and 2 slices of cheese. Okay, so what I have here, I can call this patty, P, and this I can call BS, and this I can call SC. So I have 2 of this and 2 of this, right? So if I form a hamburger, a cheeseburger, double cheeseburger over here, or just 2 slices of hamburger, so I'm gonna have my cheese, this is my bread, and I'm gonna have hamburger, and the 1 slice of cheese, and the 1 more bread. So I have those P, BS2, SC2, right? So that is my final product. So I didn't make appear anything else, or I didn't disappear of anything else, okay? So here's the diatomic molecule that I was talking before, and it's really important to know that we have those diatomic molecules, and it's easy to memorize. If you look in the periodic table, 7 makes 7. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine will always be found in diatomic, like always get together, okay? And like the hydrogen, so don't forget the hydrogen, okay? And let's practice a little bit because there's nothing better than practicing. Right? So here we have, let's separate. So we have reactant and product. So I make a table over here, reactant and product. And this side here in letter A, I will give you a trick, okay? How I do balance without like get back and doing everything again. I was like, okay, this arrow and the right, it's wrong, it's hard. So if you follow this macho rule, it's like metals. I will start with metals. If I don't have metals, I go to non-metals. And I have a carbon and a hydrogen. And by the last one will be the oxygen. How that works, let's start. So using the macho rule, I have 2 nitrogen on this side and I have 1 nitrogen on that other side. Remember, I need the same atoms and same quantity. Hydrogen I have 2 and here I have 3. So I will first, I don't have metals, so I go to non-metals. So I'll fix this. Now I have 2 nitrogen, right? So that match, good. But now I have 6 because 2 times 3 is 6, so I have a 6 nitrogen on this side. So they don't match it, right? Because this is 2 and there's a 6. So what am I going to do? 3, because 3 times 2 is 6. So now it's matching. Good and easy. So it's just like a game, just count. So let's do it again. So in this side, I have sodium, 2, and let's put it more space over here. Okay. So I have sodium, 2, and the other side I have 3. And I have oxygen, and this side I have 6, right? 1 plus 5 is 6. And the other side I have 4. And I have 1 phosphorus. No, 2. Look at this, 2. And here I have 1, right? So nothing's balanced, nothing's checking, matching. So I always start with the metal, sodium. So I have a 3 over here and 2 over here. So what I'm going to do is I'm going to put this 2 over there and this 3 I'm going to put over here. So it'll be 3 times 2, 2 times 3. So I know this is 6 and this is 6. Good. Now it's fixed. But now I mess with the other number. So 2 times P. Now I have 2 phosphorus. And here I have 4 times 2 is 8. Right? So I have 8 over here. Let's wait a bit. So let's fix this. So now I have 8. So and the oxygen on the other side. So 3 times 1 is 3 plus 5 is 8. Right? So now everything is checking. So that's a simple thing to do it, but you need to pay attention. Okay? So let's do it. I will give you time to do by yourself. Let us see and D. So if you need more time, so just stop the video and we keep it going. So the first one we did together and check if you did it right on this one. And remember, you can always ask me questions during the class and we can solve more problems during the class. Okay? So let's go to another one. Remember that I said sometimes you're going to see fractions or can use a fraction to make your life easier. And this is one of the case, but at the end, we need the whole numbers. So let's do it this one. Let's look to this. I will go to products and reactants and products. So in this side, I have 2 carbons and the other side 1. Hydrogen, I have 6 and the other side I have 2. And I have oxygen, so I have 2 and the other side I have 3, right? 2 plus 1. So nothing is matching over here. So let's do it Let me just put it only 3 over here. So let's do it carbon. Remember macho? So I start with metals. I don't have metals. I don't have no metals, which is carbon. So let's start with the carbon. So I have a 2. So I'm going to put a 2 over here, right? That'll make my life good on here. But now I change this because now I have 4 plus 1 will be 5, right? And then it says like, okay, now we go to hydrogen, right? So I have 2 hydrogens over here, and here I have 3, 6. So what I'm going to do is put a 3 over here because I know that 3 times 2 is 6. So it's matching this and this, but now I will change oxygen because I have 4 right over here plus 3 over here. So that bring me 7. Wow, 2 and 7. That's hard, right? What are you going to do? So the easiest thing to do is multiply this by 7 divided by 2 because I know that 7 divided by 2 will be 7 times 2, right? Because I have 2 this. So what I'm going to do is doing this. I know that I have 1, 7 divided by 2, 2 and 3. If I multiply the whole equation by 2, what am I going to have? 2CH2H6 plus O7O2 given 4CO2 plus 6 water. Good? So this is how you do when you get it stuck like that. The easiest way is to use a fraction, then you multiply the whole equation to eliminate that fraction. Okay? This is the solve the problem. So